Hello, everyone. This module, we're going to talk about one of the deep learning technique, which is artificial neural network. So we're going to practice that. I'm sure you know the concept of neural network. So, so without further ado, the idea that we can do to we're not going to build the neural network coding itself, but we're going to use the neural network packages. Uh, the way that we can use packages, you need to read the data first, and then if you want to train the data and test it, then given a set of data, then you need to split the data, training data set and test data sets. So as you train your neural network, and you need to test it, and then you can modify your network parameters so that it can be improved. All right. This is the idea. Given data sets here, then you need to split the data sets. I know you have the target column. We call that field to churn. And this is a subset of the row, and the rest will be here for test, and the majority for training. So as you train, then you need to indicate which field that is the target. So once your neural network is trained, then you need to test it. As you test, you need to drop the field, which is a target field, which is to churn your data. That should be dropped. So you test with this, then you can predict the result for the target field, target columns. Then finally you can compare the predicted target value and then the actual original target values. That way you see how much it is, how well it is trained. Okay. Of course, before you have these full data sets, you need to clean the data sets if there is any null values, and then normalize the data. Normalization, I know you already know, right? So this tutorial will look at Python, the functions that you may be interested in your neural network. First of all, splitting training data sets and test data sets. It is called the train underscore test underscore split. Okay. Then there's a train column and target column, and then test size. Then it'll return the training part of so we call that X train and X test. So first sequence of those, and then Y train, Y test. So 4 values obtained from this train test split. Okay. So we'll see what it is. And another another function that you may be interested in is MLP classifier. For statisticians, they may be interested in MLP regression, but we will look at only the MLP classifier. In this MLP classifier, then we need to first define the hidden layer size. Remember, there is an input layer and then output layer. In between, there's a hidden layer. If you remember the concept of a neural network. And activations, there are lots of activation algorithms available, but we're going to use, for example, RELU. There are another thing that you may be interested in is sigmoid. There are multiple others. So let's take a look at the activation, the functions, in this case, this. And the solver, this is some of the optimizer. There's an Adam optimizer is one of well known, so we simply use it. And the number of iterations are 500. But as you evaluate the result of your predictions, if it needs more, then you need to do more of this. So this is MLP classifier. Then once you set up this, then you can do, this is, if you click this, then you can see lots of the functions available with this the modules. Two of the functions that we look at is we fit the X train set and Y train set. So we need to train sets first, and then we need to predict X train or predict X test, and finally evaluate. Now we can see actual data that we dropped, right? And then predict data that we could see. So this is something that I can share with you. And the data that we are looking at, I brought up here. So we have cars data. So there are multiple columns available. We call the features. And then one of those column that is your interesting, that is your target column that you need to decide, we need to pick, right? In this case, not really much that I believe that is a sales price, right? If this kind of data, then sales price is this number. That's what this table implies. Another thing here is the dividend info. This is a little more clearer. So there's multiple other factors available. And then finally you can say, hey, with these records, will there be dividend or not? 0 means no dividend, 1 means there will be a dividend, right? Because we are not really in this area. We are not really in this area, car sales area or financial sector. We don't really understand what it is, but we know how to manipulate it. Once we know which column is a target, which attributes may be independently affect on this target columns. All right, so with that, I need to open up Python. So what we need to do is we need to, this is a deep learning using sklearn packages in Python. So we need to import pandas as PD, import sklearn, and then from sklearn neural network, we want to import MLP classifier. And then from sk learn dot model selection packages, we need to import train test split, that module, from sk learn, okay, another one is import OS. First thing that we need to do is change the directory, and then we'll find out where this, for example, cars located. So we need to get the path expression and then copy that here. And then we need to read the CSV of that, from there, cars.csv. And then we have a pointer to that table, let's say TF. And then simply let's try to print TF. Okay. And what I want to, if you do not have this, then you need to install it. But I have that here on the other, so it'll, okay, so cars is red, right? Well, this kind of things we already learned, right? All your week, how to read. And then we need to define target column. Target column is nothing but sales, all right? And then predictor. Predictor is the rest of the columns. So column can be found df dot columns, right? So if you run that much, then the column is age, gender, that is the column. So basically, so list of tf dot columns, then there will be a list, and then we want to change this to set. For example, target call is, or target call not yet run. So do this, and then target call is a list. If you want to change that to set, then you need to do target calls, then it'll be a set, like that. If it is a set, then we can make a set minus, right? This list needs to be also convert to set, and also that targets needs to be converted to set. So if we do this, okay, copy and paste here test, see what it is, then that is still set. But if we convert that to list, inside, if you copy that and hit enter, then it'll be a list. That's what we want to have. So target column is a list, and predictor, that is also list. Everything is a list. Okay. Then we need to do optimizations. Not optimization, normalizations. So actually what we need to do is df predictor. Predictors is only the rest of those, right? These are all the columns, but sales. So sales dropped. So predict, I would say this is predict column. So predict column. df predict column. If we say df predict column, then it'll be df is entire data frame, right? So we apply that table format, data frame. Only we take out. This is still data frame, but we look at only those columns. So it has some of the values. What I am trying to do is I want to like normalization. So for each if it's a data frame, the beauty of data frame is this: df and then ag. In the ag columns, here ag, what is the maximum value there? That we can find. Max, then maximum age is 60. And also, for example, others, income here, maximum income. Then that is 11,000, right? So actually we need to divide each of the values can be divided by the maximum values. Then it'll be normalized. And then we call that normalized, that is, anyway, that is a TF, right? So we predict COL. That's still DF. Let's call it DF. Okay. So after this, then DF, if we call DF describe function, and it'll be already normalized. Income is not. So all point sum, right? Yeah, something like this. After that, we need to define X. That's a training data set. Training data set is nothing but predict columns and values. That is X. And Y is df target column and values and label, because we want to change it columns and rows. So we have X and Y. X is a array of the values. This is simply a single values. So there is a small y. That's what we assume. And then we need to do split. Train, test, and train, test, and split. There we need to put X and Y, two values, and test size is 0.05, which means 5% training and 95% no, 5% test and 95% training data sets. And then some of the random state 40, that's simply the stabilizer. And then this guys returns 4 values, okay, as we looked at. So X train and X test. X train is training data sets, but only so without the targets, right? Target well, it gives the targets, and X test does not. It dropped the target columns. So X train, X test, and Y train, Y test. Right? 4 values will be returned. Y train and Y test. 4 values returned. So if we run this, then we can say here, what is X train? X train. X train is arrays of this whole 1, 2, 3, 4, only 4, 1, 2, 3. See here, 2, 3, 4 values. So out of df columns, let's say df columns right now, age, gender, miles, 1, 2, 3, 4, 5, 6. Okay, let's see, X test. X test. It's a lot more, but still 1, 2, 3, 4 values. And then Y train. Y train has 1, 2, 3, 4, 5. Oh, this is all the values. Only I think the target values. Right, this is sales price. And then Y test. Then only those are smalls. This is the actual data. And this guy needs to train the neural network, and therefore when we test the X test, this XY, this is trained data sets. X and Y, those are trained data sets. But Y, the values in these trained data sets is the target values. The other values here. Same thing, test data sets. This is the test records for test, but we don't know the actual, we don't know values for target. So target columns dropped here, X test. Okay, here small Y test, then this guy has your real actual values. That's what it is. So if you want to see what it is, then you can see it, print xtrain dot shape, and then xtest dot shape. This is the real test values, and this is train values for those the records. Here, this train data sets, it has age, gender, miles, debt, income, sales, everything about the train sets. But it knows this is a target, right? And this test sets, X test, it has so 5 of 9, 14, and 5 over 49, something like that. Okay, so we'll see that. This is a tuple formats. Somehow this guy has that. So once we have that, then we need to MLP classifier. So let's see MLP classifier. This classifier first set hidden layer size. Then we can say let's say 5, 5, 5. So internally we have 5 nodes and 5 nodes and 5 nodes. Those are all connected like neurons. And then activation function. Activation function is ReLU. And then solver is Adam. And then maximum iteration. Maximum iteration equals, let's say, 500. And we call this, say, MLP. MLP stands for multi-level predictor. So classification is nothing but predictions. And this MLP needs to fit function xtrain. That's a train data sets, and we need to say, hey, this is the target. Okay. If this fits well, then we can say MLP predict. We can predict X test, right? And then we call that predicted test. And then we can say, yeah, let's up to this, try to run up to this point, okay? Okay, there is a unexpected keyword, hidden layers, hidden layer. Hidden layer size is plural. Okay, it runs. Yeah, like optimizer says 500 is too small. So we need to increase the 500 iteration. Where is it? Here. Let's say 100, 1500. So yeah, it is a predict. So if we see predict test, that is predicted. Actual is, yeah, actually is not really. So I think what is Y test? Y test. This is the actual. So if we compare, this is very similar, right? 29, 21, 9. This is far different. This is that much. This is it's not really bad, right? But if we increase that iteration 250, then I think it'll be better. Let's try to 350. Okay, so it takes a little while to get that, right? Of course, there is a the evaluation. The function is math is available, so I will introduce to you. But manually, we can see how much they are improved. This is with the 1,500 iteration. We have this. This is the actual ones. So I will get this again. Predict test. Then we may be able to see. Look at this. This has been improved, that you can see. Oops. I want to make this a little smaller. Okay. All right. The first, 1500 iteration. The first value is 1089. Here 15,064, which is closer to actual data. 15,820, right? So it goes that way. It's some improves. If we could do this a lot more, then eventually it'll fit, right? The way you can test this, let me tell you here. To evaluate, you have to classification reports. So simply copy this. So from skeleton matrix packages, we want to import classification report and confusion matrix. So Y-train and Y-train and predict train. That is, we call that predict test, right? So predict test. Change this. Predict test. Then we will get some the report that you can get from sklearn packages. There's some matrix. So we can use this to evaluate our neural network. This is much simpler, right? As you improve this, as you change the iterations, it's not really the true the maximum iteration becomes always good. If it is the case that there is overfitting, it's not really well-fitting. Well-fitting is really, really important. This is from the packages. Let me see one by one. See if it works for confusion matrix or classification report. So which one has it? Yeah, confusion matrix has an error. Classification matrix. this is some errors. What about this? Well, anyway, let's forget about this. So we don't, let's try to do manually. That's fine. The other one that we can try, as I said, this dividend, this financial data, maybe this is more churning column. So if we use that, then we may have a little better the result. So let's say there's a dividend info.csv, and then churning column is dividend, so we call here dividend. We may have a little better result. So let me, other than that, it remains the same because all others okay. So execute it. Oh, execute so quick. Let me see. Let's see. Oh, execute so quick. So what we want to do here, we want to see predict test. That is this 11000, that, and what is it? The other one is actual, right? So y underscore test. So y underscore, then it is this. Oh, it's perfectly predicted, right? 1100011. Yeah. One of the reasons that why this is perfect prediction, that is because this churn data. This churn data is more clear than here sales data. This churn data, literally, it tells us the clear classification. It's like a label. This is not really a label, right? This is there are so many different numbers available, so that may be the reason. Classification is classification, so we need to classify a limited number of beans, groups. So if we choose the columns that can churn the records more clearly, then the neural network can be trained accurately. That's what we learned with this specific two different data sets. Okay, hope you learned something from here. Thank you so much.